Teachers organised activities for 3 classes of 24 pupils and 4 classes of 28 pupils. What was the total number of pupils involved?
In this question, we are told that there are 3 classes of 24 pupils and 4 classes of 28 pupils, and the question asks us to find the total number of pupils. So the calculation that we need to do is 3 multiplied by 24, and we need to add that onto 4 multiplied by 28. So we first need to do 3 times 24 and then 4 times 28. Well, we can do 3 times 24 as follows: 4 3s are 12, 2 3s are 6 with a 0, that gives us 72. And to do 4 times 28, well, multiplying by 4 is the same as multiplying by 2 twice. So we could say that 2 times 28 is 56, times by 2 again gives us 112. If not, though, we could just do it in a grid as before. 8 4s 32, and 2 4s are 8 with a 0. And when we add those together, we're going to get 112. And so what we need to do is we need to do 72 plus 112. Well, 2 plus 2 is 4, 7 plus 1 is 8, 1 plus 0 is 1. So we have 184. That is the answer.
All 30 pupils in a class took part in a sponsored spell to raise money for charity. The pupils were expected to get an average of 18 spellings correct each. The average amount of sponsorship was 20 pence for each correct spelling. How many pounds would the class expect to raise for charity?
In this question, we are told that 30 pupils compete in a sponsored spell for charity. So in total we have 30 pupils. Now we are told that each pupil gets an average of 18 questions correct. So that's a total of 30 multiplied by 18 questions correctly answered. And for each question we are told that they raise 20 pence. So that's a total of 30 multiplied by 18 multiplied by 20 pence. So we just need to evaluate this multiplication. Well, let's do 30 multiplied by 20 first. That gives us 600. So we have 600 multiplied by 18. So let's do this calculation. So we've got 618. Well, 8 6s are 48 with 1 2 zeros. And 1 6 is 6 with 1 2 3 zeros. And when we add all these together, we are going to get 10,800. But remember, this is in pence, so we need to divide this by 100 to get the answer 108. So the answer to this question is £108.
As part of the numeracy work in a lesson, pupils were asked to stretch a spring to extend its length by 40%. The original length of the spring was 45 centimetres. What should be the length of the extended spring? Give your answer in centimetres.
In this question we are asked to extend the length of a spring by 40%. Now the original length of the spring is 45 centimetres. And we need to find a 40% increase of this. Well, if 100% is 45 centimetres, then 10% is 4.5 centimetres. So 40% is 4.5 times 4 centimetres. And we can times by 4 quickly by multiplying by 2 twice. So 4.5 multiplied by 2 is 9, multiplied by 2 again gives us 18. So 40% of 45 is 18. So a 40% increase is going to give us 45 plus 18. And when we add these together, we are going to get 63. So the answer is 63 centimetres.
For a science experiment, a teacher needed 95 cubic centimetres of vinegar for each pupil. There were 20 pupils in the class. Vinegar comes in 1,000 cubic centimetre bottles. How many bottles of vinegar were needed?
In this question we are told that a teacher needs 95 cubic centimetres of vinegar for each of the 20 pupils in a class, and we are given that the vinegar comes in bottles of 1,000 centimetres cubed. And the question is, how many bottles do we need? Well, if we have 95 centimetre cubed for each of the 20 pupils, then we have 95 multiplied by 20, which is, well, to multiply by 20, that's the same as multiplying it by 2 and timesing it by 10. So 95 times 2 is going to give us 190, times by 10 is going to give us 1,900. So that's 1,900 cubic centimetres, but vinegar comes in 1,000 centimetre cubed bottles, so we're going to need at least 2 bottles.
The morning session in a school began at 9:25. There were 3 lessons of 50 minutes each and 1 break of 20 minutes. At what time did the morning session end? Give your answer using the 24-hour clock.
So in this question we are told that the morning session began at 9:25. We are given that there are 3 lessons of 50 minutes each and 1 break of 20 minutes, and we are asked to find the time in which the morning session ends. Well, all we need to do is work out the total duration of the lessons and the break. Well, we've got 3 times 50 minutes, so that's 150 minutes, but then we've got a 20-minute break to add on, so that actually becomes 150 plus 20, 170 minutes. And now we need to work this out in terms of hours and minutes. Well, 170 is 120 plus 50, right? And 120 is 2 hours, so we've got 2 hours, 50 minutes. So all we need to do is add 2 hours, 50 minutes onto 9:25. And if we do that, we get 0 plus 5 is 5, 5 plus 2 is 7, 9 plus 2 is 11. Now we get 1175, but we have to remember when we reach 60, we roll on to a new hour. So this is the same as 12:15. And that's because 75 is 60 plus 15. So the answer is 12:15.
6 out of 25 pupils scored full marks in a test. What percentage of pupils scored full marks?
In this question we are told that 6 out of 25 pupils scored full marks in a test, and we are asked to find the percentage of the pupils that scored full marks. Well, we first need to find the proportion then. Well, we have 6 out of 25. And we need to find out what this is as a percentage. Now we could try and reduce the fraction, but that's not going to work. So the next thing we could do is we could do 6 divided by 25 in short division. Now that's quite a long-winded way of doing this. The best way to do this is to notice that this denominator here is 25. And we know that 4 times 25 is 100, and percentages are always out of 100. So if we can get that bottom to say 100, then we'll have our percentage on the top. Now remember with fractions, if we multiply the numerator and denominator by the same number, the fraction doesn't change. So let's multiply the numerator and denominator by 4. So we get 6 times 4 gives us 24, and we get 25 times 4 gives us 100. So now the fraction hasn't changed. We know that 6 out of 25 is obviously the same as 24 out of 100, but 24 out of 100 is obviously 24%. And that is the answer.
What is 643 divided by 0.1?
In this question we are asked to find 643 divided by 0.1. Now this is one we recommend that you learn off by heart, that dividing by 0.1 is exactly the same as multiplying by 10. We always recommend you remember this, okay? So the answer to this question is 6430, or 6,430. Now if you didn't remember how to do this, there is another way around it, okay? So 643 divided by 0.1. Well, what is 0.1 as a fraction? Well, that's 1/10, okay? So dividing by 0.1 is obviously the same as dividing by 1/10. But remember, if you divide by a fraction, that is the same as multiplying by its reciprocal. And by reciprocal, I mean if we flip the fraction. So this is the same as multiplying by 10 over 1. But we know that 10 over 1 is just 10. So this is just the same as multiplying by 10. So we can see that 643 divided by 0.1 is exactly the same as 643 multiplied by 10.
In a class of 24 pupils, 3 need additional support. What fraction of the class do not need additional support? Give your answer in its lowest terms.
In this question we are told that there are 24 pupils and 3 need additional support, and we are asked to find the fraction of the class that do not need additional support. Well, I think in this question it's probably easier to first find the fraction that do need extra support. So the fraction is 3 out of 24, and we just need to reduce this. Well, notice 3 and 24 are both multiples of 3, so we can divide both the top and bottom by 3. And 3 divided by 3 gives us 1, 24 divided by 3 gives us 8. So if 1/8 of the class needs extra support, that means that 7/8 of the class do not need extra support. So that is our answer.
A teacher took a group of pupils to an aquarium whilst visiting France. The total entrance cost for the group was €160. Taking €1.6 as equal to £1, what was the total entrance cost in pounds for the group of pupils?
So all that we need to do in this question is to work out essentially what €160 is equivalent to in pounds. But we are given this conversion here, that €1.6 is equivalent to £1. So the question we need to ask ourselves is, how can we get this left-hand side here to say 160? Well, we can do that by multiplying both sides of the ratio by 100. And if we do that, on the left we're going to get 1.6 times 100, which gives us 160. And on the right we're going to get 1 times 100, which is 100. So we can see that €160 is equivalent to £100. So the answer to this question is £100.
A pupil achieved 84 marks out of a possible 120 in a test. What percentage mark did the pupil achieve for the test?
In this question we are told a pupil achieved 84 marks out of a possible 120 in a test, and we are asked to find the percentage mark that the pupil achieved. Well, we need to first find the proportion, as usual, so we have 84 out of 120, and again we need to simplify this fraction. Well, this one's quite a tricky one, and if you can't spot it right away, what I advise you do is notice that both the top and the bottom are even numbers. So what you can do very quickly is divide the top and the bottom by 2. So this reduces to 42 out of 60. And again, they're even again, so we'll do it again. So we get 21 out of 30. Now at this stage you can probably spot that these are both multiples of 3. Okay? So 21 is going to be 7 threes, and 30 is going to be 10 threes. So the proportion is 7 out of 10, which is of course 70%.
A school trip was planned at a total cost of £120 per pupil. The accommodation cost 2/5 of the total. What was the cost of the accommodation per pupil?
So in this question we are given that the school trip cost £120 per pupil, and the accommodation was 2/5 of this total. And the question asks us to find the cost of the accommodation per pupil. So all we need to do is find 2/5 of 120. In other words, 2/5 times 120. So we have options here. We can either do 120 times by 2 and then divide that answer by 5, or we can do 120 divided by 5 and then times the answer by 2, and that's equivalent to finding 1/5 of 120 and then times it by 2 to find 2/5. So I'm going to opt to divide by 5 first. Now remember, when we divide by 5, that is the same as multiplying by 2, then dividing by 10. So 120 divided by 5 is the same as 120 multiplied by 2, 240 divided by 10, 24. So we have 24. And now all we need to do is times that by 2, which gives us 48. So the answer to this question is going to be £48.
A school's policy for Key Stage 2 was to set 3.5 hours of homework per week. What was the mean number of minutes to be spent on homework per weekday evening?
Here we are told that school's policy for Key Stage 2 was to set 3.5 hours of homework per week, and we are asked to find the mean number of minutes to be spent on homework per weekday evening. Well, there are a couple of ways we can do this. We could either convert this into minutes first, and divide that by 5, Or we could divide this by 5 first, and then convert that answer to minutes. But I think it's probably easier in this example to convert this into minutes first. So what's 3.5 hours in minutes? Well, we've got 3 hours, which is 3 times 60, which is 180. And then we've got another 0.5 hours, so that's 30 minutes. So if we add these together, we're going to get 210. So they get 210 minutes of homework each week. And now we need to divide that by the number of weekdays, which is going to be 5. So we need to do 210 divided by 5, well remember, to divide by 5 we multiply by 2, 420, divide by 10, 42. So the answer is 42 minutes. In this question we are given a scatter graph that compares reading age against actual age. And the question asks us to find the proportion of the class that have the same reading age as their decimal age, and it wants us to give our answer as a decimal to 1 decimal place. So what we first need to do is to find the number of points on the graph that have the exact same actual age as they do reading age. Now notice with these types of graphs we don't usually have this blue line in here, and this is in fact the y equals x line. And the reason this has been put in here is because anything that lies on this line has the same reading age as actual age. So all we need to do is to count all the points that are on the line, and we can see we have 1, 2, 3, 4, 5, 6. So we have 6 points in total, and we are told that there are 21 pupils in the class. If we weren't given that, we would have to count all the dots and we would get 21. So the proportion is going to be 6 out of 21, and if we type 6 divided by 21 in our calculator, that gives us 0.28571 ... But we need to round this to 1 decimal place, so we're going to round this up to 0.3. In this question we are given the scatter graph from question 1, and we are now asked to click on the pupil who had the greatest difference between their reading age and actual age. Now in the last question we noticed that the graph had this y equals x line in here, in blue, and we determined that any point on that line represents a student who had the same reading age as actual age. But if we want the biggest difference, we want to pick the point that's furthest away from the line. And that will be this one. So if you have a look here at the distance for this point, it's much higher than any other distances to the line, okay? So the answer for this question is this point here. In this question we are given a scatter graph that compares reading age against actual age, and we are asked to find the range of reading ages for the pupils in the class. Well, notice that reading ages is on the vertical axis here. So we need to find the difference between the highest and lowest reading age. Well, since reading age is on the vertical axis, we need to look for the highest dot and the lowest dot. And we can see that the highest point is here, and the lowest point is here. So all we need to do is to work out what this value is, and we can do that by reading off from the graph. So we can see here, if we go all the way across, we can see that represents a reading age of 7 years and 7 months. Likewise, if we take the lowest age here and we read across, that represents a reading age of 5 years, 10 months. So all we need to do is to work out the difference between 7 years, 7 months and 5 years, 10 months in months. One way we could do this is say 7 years minus 5 years is 2 years, which equals 24 months, and then 7 months minus 10 months is minus 3 months. So we could do 24 minus 3, which gives me 21 months. The other, perhaps more logical way of doing it is to work out the total number of months. So 7 years, 7 months, what we could do is say, well, that is 7 times 12, which is 84 months, plus another 7, 91 months. And then 5 years, 10 months, well, we could say that 5 years is 5 times 12, 60 months. And then we could say 60 plus another 10 months gives me 70 months. And the calculation we could do there is 91 minus 70, which gives us 21 months. In this question we are given a table that tells us about the number of pupils in a school that are having extra music lessons, and the data is split up into 8 different classes. The question asks us to find the percentage of pupils in the school that are having extra music lessons, and it wants our answer to the nearest whole number. Well, the proportion of people in the school having music lessons is going to be the total number of people having music lessons divided by the total number of pupils. So what we first need to do is find the total number of pupils, and we can do that quite easily by adding up all the values in this column here. And so when we do that, we get 25 plus 30 plus 30 plus 28 plus 26 plus 29 plus 18 plus 24, and that gives us 210, so there are 210 pupils. Now we're going to total up the other column to find out what was the total number of pupils who had extra music lessons. And when we do that, we get 5 plus 5 plus 5 plus 7 plus 5 plus 6 plus 6 plus 5. And that equals 44. And so the proportion is 44 out of 210. And if you do 44 divided by 210 in your calculator, you get that that equals 0.2095 ... But it wants our answer as a percentage, so we need to multiply that by 100 to get 20.95 ... But finally, we need to give our answer as a whole number, so we're going to round this up to 21%, and that is the answer. In this question we are asked to find the mean point score for the year group, and we are given this formula here. So all we need to do is use this formula to work out the answer. Now the problem is, we don't know the total points for the year group, but we do know the total number of pupils in the year group. That's given to us in the question, that there are 48, but we can also see that from the table here under the total that there are 48 pupils. So what we first need to do is work out this column here, the total points per level, and we can see that this is simply the number of pupils multiplied by the points per level, and that makes sense. So if you have 5 pupils and they each get 21 points per level, then there is a total of 5 times 21 equals 105 points in total. So the calculation we need to do, well, we need to first do 8 multiplied by 33, and if we do that we get 264, and then we need to do 6 multiplied by 39, which gives us 234. And now what we need to do is add up all of these values in the total points per level column. So we need to do 105 plus 783 plus 264 plus 234, and if we do that we get 1386. So there were 1386 points in total, and now we have all the information required to use the formula. So the mean point score is going to be 1386 divided by 48, which gives us 28.875. But the question asks us to round our answer to the nearest whole number, and when we do that we get the answer of 29. In this question we are asked to find the proportion of the class that can speak 4 languages. Now if we look to the pie chart here, we can see that it is the yellow sector that represents students who can speak 4 languages. And we can see that there are exactly 3 pupils out of a maximum of 29. We can see here that there's 29. So the proportion is 3 out of 29. Now as this is on the written section, we can use a calculator to work this out. So we're going to type in 3 divided by 29 on our calculator, and that will give you 0.10344 ... Now it wants our answer rounded to 1 decimal place. So this means that the answer is going to be 0.1. In this question we are given 2 way tables and we are asked to indicate all the true statements. The first one claims that half of the pupils taking geography achieved grades B or C in mathematics. Well, we can see from the geography table here that there are a total of 98 pupils. So half of 98 gives us 49. So we just need to read where it says GCSE Mathematics here, scroll all the way along from B to C, and we can see that the total is 49. So this statement is true. The next statement claims that more than 3/4 of the pupils taking history achieved a grade E and above in history. Well, we can see from the history table here that there are a total of 52 pupils that got a grade E or above in history. So we first need to work out what 3/4 of 52 is. And if we do that calculation, we will get that this is equal to 39. So we need to check that more than 39 pupils achieved a grade E and above in history. Well, let's have a look at the history table. If they got an E or above, that means they got either an A star, an A, a B, a C, a D, or an E. So we just need to add up these three totals here. So we need to do 5 plus 22 plus 14. And when we do that, we get 41. So we can see that this statement is also true. Finally, let's have a look at the last statement. This claims that less than 10% of the pupils taking geography achieved an A star or A in geography. Well, there are 98 pupils that took geography, so 10% of 98 is 9.8. So we need less than 9.8 pupils who took geography to achieve an A star or A. In other words, 9 or less. Well, we can see from the table here that 13 students got an A star or A in geography, so that statement is false. In this question we are told that a school's parents' evening starts at 16:30 on each of 2 consecutive days. We are also given that there are a total of 24 appointments and they last 10 minutes each, and we are given that the teacher takes a 20-minute break on each evening. The question asks us, what is the earliest time the teacher can expect to finish on the second evening, knowing that the teacher finished at 7 PM on the first evening? Well, if the teacher finished at 7 PM on the first evening, and the parents' evening started at 16:30, then the difference between those two times is 2 hours and 30 minutes, which is 150 minutes, which is 130 minutes of appointments, because they had a 20-minute break, which is 13 appointments. So there were 13 appointments on the first day. But there's a total of 24, and 24 minus 13 gives us 11. So on the second day there are 11 appointments. Well, 11 appointments last 110 minutes. So in total, the second evening lasts 130 minutes, including the 20-minute break, which is obviously 20 minutes shorter than the first day. So the teacher gets to finish at 18:40 on the second day. And that is the answer. In this question we are told that a teacher produced the following table to show the marks achieved in an end-of-year geography test by pupils in 3 Year 7 classes. And we are asked to indicate all the true statements. Now the first statement claims that some pupils in Class A achieve less than 12%. So let's first have a look at the stats for Class A. So we can see that there's a range of 60, a median of 50, and a mode of 72. Now we find that the best way to approach these questions is to draw a generic box plot here and to put those values on. Well, we know that the median is 50, and this line always represents the median. We know the range, which is the distance between the highest and the lowest mark, is 60. And we know the mode is 72. Now the annoying thing is we don't know on the box plot where 72 lies. It could be the highest mark here, it could be the upper quartile, it could be somewhere in between. We don't know. So all we know is somewhere we've got 72, but we do know it is above the median because the median is 50. Somewhere in the dataset lies 72, and that is the mode. Now the question states that some pupils in Class A achieve less than 12%. So for this statement to be true, we have to prove that in every possible instance, that at least one person achieved less than 12%. So let's see whether we can create a scenario in which someone got less than 12%. Well, the mode is 72, okay? So we know someone got a mark of 72, because it's the most common. At least 2 people must have got a mark of 72 for it to be the most common. But the range is 60, right? So if 72 was our highest mark, which it might not be, 72 might be here, our highest mark might be 82, we don't know. But if it is our highest mark, i.e. we're making this as small as possible, the range would take us to exactly 12. So even if our highest mark is 72, the range will only take us down to 12, not less than 12. Can it be smaller than 12? Well, no, it can't. Because for your lowest mark to be less than 12, that means your highest mark has to be less than 72, 71 or less. But we know someone got a mark of 72, so you can't have a highest mark of 71 or less. So this means that this statement here is false. Now let's have a look at the second statement. Well, the second statement claims that at least one pupil in Class C achieved less than 20%. Well, again, let's have a look at the statistics for Class C. So we can see here that the range is 85, the median is 60, and the mode is 70. So let's put these onto a generic box plot again. The median 60, the range here is going to be 85, and the mode is 70, which is above the median somewhere. It's here somewhere, but we don't know exactly where it could be. It could be the highest mark, it could be the upper quartile, anywhere in between. We don't know where the mode exactly lies on the box plot. Now it says that at least one pupil in Class C achieved less than 20%. Well, this statement is definitely true. And the reason is as follows. We know the range here is 85, okay? So the maximum mark is 100. So even if the highest mark was 100, that range would take us down to 15. So even if someone got full marks in the test, then that means that the lowest mark was 15, which is less than 20. But as you can see, if we made this 90, so the highest mark was actually 90, so no one got 100%, someone got 90, then the range would take us down to 5. Always less than 20. In fact, if that mark was exactly 20, okay, so let's pretend the lowest mark was exactly 20, the range would take us all the way up to 105. But no one got 105%, so the highest mark can't be 105%. The highest mark can be is 100, in which case someone got 15. So this statement is definitely true. So let's go and have a look now at statement 3. Well, this claims that all pupils in Class B achieved at least 40%. Well, let's have a look at the stats for Class B. We can see from the table the range is 28, the median is 50, and the mode is 68. Again, we can put this into here. The median is 50, the range is going to be 28, and the mode is 68, so again, it's somewhere above the median, but we don't know where. Now, it says all pupils in Class B achieved at least 40%. Well, this statement is actually true, because we know the range is 28 and the mode is 68. So let's make the highest mark as small as possible. Well, the smallest that highest mark could be is 68. It can't be less than 68 because someone got a score of 68. Now, if the highest mark was 68, the range takes us to 40. So if we make that highest mark as small as possible, we actually get that the lowest mark was 40. But to be honest, the mode probably isn't the highest mark. It might be 78. That's the biggest it could be, is 78, because that would mean that 50 is the lowest mark, and then the range would take us up to 78. And the lowest mark can't be bigger than 50, because someone got a mark of 50. So that's the way to approach this question, and this is the way we advise you approach these kind of questions in the future. So of course this statement here is also true. With these sorts of questions it is quite tricky. We advise you create a box and whisker plot and you give it a go and try adopt some simple logic. Don't spend too much time on this question, because if they do crop up, you're only going to get one question like this in your test. Okay, and you can always have a guess if need be. In this question we are given a table representing the Test 1 and Test 2 marks of 10 pupils. And the question asks us to click on letters in the table for the pupils who scored at least 10 percentage points more in Test 2 than in Test 1. Now what we could do is work out what the percentage scores was in both tests and then deduct them from each other, but that seems a little bit like a waste of time. In fact, we can see from the table here that the pupils' marks are out of 50. So for example, a mark of 30 out of 50 is a mark of 60 out of 100, 60%. So all of these, in theory, to get into percentages, all we'd have to do is double the numbers anyway. But I think the best approach for this question is to first work out the difference between the Test 1 and Test 2 marks. So if we look at pupil A, we can see they had a Test 1 mark of 28 and a Test 2 mark of 30. So that's a difference of +2 in Test 2. Likewise, with pupil B, there's a difference of +4, with C, -1, with D, +5, with E, +4, with F, +9, with G, +2, with H, +5, with I, there is no difference at all, and with J, there is +10. So going back to pupil A, there's a difference of 2, but remember, this is a difference of 2 out of 50. So as a percentage, that's going to be 4 out of 100, 4%. And we're looking for all the numbers that are greater than or equal to 10. So all we need to do is actually double out the differences that we have here to get the percentage point difference. So from A we would have 4, B we would have 8, C we would have -2, D would have 10, E would have 8, F 18, G 4, H 10, I 0, and J 20. And we can see just from that list that the ones that had a percentage point difference greater than or equal to 10 were D, F, H, and J. In this question, we are given a box and whisker diagram that compares the percentage test marks between two classes, Class A and Class B. And the question asks us to identify all the true statements. Now the first statement claims that the range of percentage marks was greatest in Class A. Well, remember that the range is the difference between the highest and the lowest mark. So it's this distance here. So for Class A, the highest mark was 60 and the lowest mark was 30. So there's a range of 30 there. But what we're more concerned about is just the size of this, okay? And in Class B, if we do the same, we go from 60, 35. There's a range of 25. So clearly it is greater in Class A. But we could have just spotted this visually. You can see this line is a lot longer than that line. So we didn't need to involve any numbers here. We could have just simply looked at the diagram and would have seen that Class A had the bigger range. And so statement A is true. The next statement claims that the median percentage mark in Class A was 15 percentage points less than the median percentage in Class B. Well, we can see the median is always this middle line here. So the median for Class A was 45, the median for Class B was 50. So the median for Class A was only 5 percentage points lower. So that statement is false. Finally, the last statement claims that the interquartile range was the same in both classes. Well, the interquartile range is the difference between the upper quartile and the lower quartile, i.e. this distance here for Class A and this distance here for Class B. We can see again visually these distances are the same, but if you wanted to add numbers to it, we can see this is a difference of 10 and this also is a difference of 10. So both classes had an interquartile range of 10. Therefore, the statement is true. In this question, we are asked to find the latest time that the coach should leave Brussels. Now, the key bit of information we are given is that the teacher wants to be there no later than 1800. The distance is 120 kilometres. And the coach will travel at an average speed of 50 miles per hour. We are also given the conversion that 5 miles equals 8 kilometres. So what I think the first thing we need to do here is to convert the 120 kilometres into miles. Well, we are given the ratio that 5 miles is 8 kilometres. Well, that means that 1 kilometre is 5 divided by 8 miles. So then we can just multiply this ratio by 120, because then we're going to get that 120 kilometres equals 120 times by 5 over 8 miles, which is 75 miles. So 120 kilometres is 75 miles. Now we are given that the coach travels at 50 miles per hour. So that means it does 1 mile in 1 divided by 50, 1 over 50 of an hour, which means it does 75 miles in 75 divided by 50 of an hour, which is 1.5 hours, which is 1 hour 30 minutes. So what we need to do then is 1800 minus 1 hour 30 minutes, which gives us the answer of 1630. In this question, we are given a pie chart that shows the destination of Year 13 leavers, and the question asks us to indicate all of the true statements. The first statement claims that 3/7 went on to higher education. Now there are a couple of ways of doing this, but the way I would recommend is to first find out the total number of pupils. So all we are going to do is add up the numbers in the pie chart. So we're going to do 48 plus 38 plus 14 plus 82. And if we do that, we get 182. Now what I would probably do is find what a seventh would be. So a seventh of 182 is 182 divided by 7, which is 26. That means that 3/7 are 3 times by 26, which is 78. So if 3/7 went on to higher education, that means that 78 people went on to higher education. But we can see from the pie chart here that 82, in fact, went on to higher education. So this statement is false. The next statement claims that 1/13 of the students took a gap year. Again, we know the total is 182, so a 13th of 182 is 182 divided by 13, and that gives us 14. So if 1/13 of the students took a gap year, that means 14 students took a gap year, and we can see from the pie chart that 14 did. So that means that this statement is true. Finally, the last statement claims that 2/7 of the pupils went on to further education. Well, we know from part A that 1/7 was 26, so 2/7 are going to be 52. So the question is, did 52 students go on to further education? Well, we can see from the pie chart that 38 did, so this statement is false. In this question we are given a bar chart representing the Test 1 and Test 2 marks of 30 pupils, and the question asks us to indicate all the true statements. The first statement claims that the number of pupils achieving 81 plus marks increased by 50% from Test 1 to Test 2. Well, we can see in Test 1 we had exactly 2 students who got a mark of 81 or above, and in Test 2 this increased to 6. So we need to find the percentage increase between 2 and 6. Well, let's assume that there was a 50% increase, and then if we increase 2 by 50%, that's the same as saying 2 multiplied by 1.5, which gives us 3. So if there were a 50% increase, we would have had 3 pupils got a mark of 81 plus in Test 2, but we don't. We have 6, so we know that this statement is false. The other way we could do this would be to find the percentage increase between 2 and 6. Well, we can just see that 6 is 3 times 2, so it's an increase of 200%. The second statement claims that more than 80% of pupils achieved more than 40 marks in Test 2. Well, we can see using the graph here that if we're looking for a mark of 41 or above, we're looking for anyone who got a mark of 41 to 60, 61 to 80, or 81 plus. So in Test 2 that gives us a total of 13 plus 6 plus another 6, and when we do that we get 25. Now 80% of 30 is the same as 0.8 multiplied by 30, which gives us 24. So if more than 80% of the pupils achieve more than 40 marks in Test 2, that means that more than 24 pupils achieve more than 40 marks in Test 2, and we now know that there were a total of 25 students, which is bigger than 24, so this statement therefore is true. Finally, the last statement claims that 1/3 of the pupils achieved fewer than 41 marks in Test 1. What we can see from the graph, if we're looking for less than 41 marks in Test 1, we have a total of 3 plus 7, so we have 10 pupils. Now a third of 30 is 30 divided by 3, 10, and we have that 10 pupils achieve fewer than 41 marks in test 1. So this statement here is true. In this question we are given a table that shows the marks achieved by 3 pupils in coursework and in a practice examination. We are given that the teacher has set a minimum final percentage mark of 55 for a predicted grade C, and we are given this formula here to calculate the final percentage mark. And the question asks us to click on the letter of the pupil X, Y or Z who is predicted to achieve a grade C. We'll notice in the formula that it has coursework percentage mark and practice examination percentage mark. So we have to be a little bit careful because in the questions we are given the mark, we are not given the percentage mark. So what we first need to do is to find the percentage marks. Well, we are given for the coursework the mark is out of 60. So for pupil X, the percentage mark is going to be 22 divided by 60 times 100, and we get 36.66666%. With pupil Y, we do 21 divided by 60, multiply it by 100, we get 35%. And with pupil Z doing the same thing, 30 divided by 60, multiplying that by 100, we get 50%. Now when we have a look at the practice examination mark, we are actually given that these are out of 100. So these are in fact percentages anyway, because 45 out of 100 is 45%, etc. So what we need to do now is input these marks into the formula. So let's start with pupil X. So we have a coursework percentage mark of 36.666 and a practice examination mark of 45. So the formula is 36.666 plus 3 lots of 45, all divided by 4, and that gives us 42.91666, which is too small to be a grade C. Let's have a look at pupil Y. So we have a coursework percentage mark of 35%, and a practice examination mark of 60, so the formula is going to give us 35 plus 3 lots of 60, all divided by 4, which gives us 53.75, again a little bit too small. So we know that the answer to this is probably going to be pupil Z, but we're going to compute it anyway just to check that we are right. So with pupil Z we have a coursework percentage mark of 50, and a practice examination percentage mark of 58. So the formula is going to give us 50 plus 3 lots of 58, all divided by 4, which gives us 56, which is bigger than 55, so this is a grade C. So the answer to this question is pupil Z. In this question we are given a table that compares the teacher assessment and test and task results over a 3-year period. The question asks us to indicate all of the true statements. The first statement claims that in 2009 the teacher assessment result for each subject was above the corresponding test and task result. Well, let's have a look. Here's the 2009 column. Let's first start with English. We can see the teacher assessment was 68 and the tests and tasks was 60, so it was higher in the teacher assessment. In mathematics, again, we have 66 versus 56, so it was higher in the teacher assessment. And in science, we have 76 for the teacher assessment and 82 for the tasks. As you can see, 76 is less than 82, so this statement is false. The second statement claims that in 2010, the teacher assessment result was closer to the test-task result in English than it was in science. Well, let's have a look. In 2010, for English, we have a teacher assessment score of 72 and a test-task score of 70. That's a difference of 2. Whereas with science, we have 77 versus 74. That is a difference of 3. So it was closer in English, but by 1 mark. Finally, the last statement claims that taking into account both teacher assessments and task assessments, the trend in both English and mathematics indicated improved performance. Well, let's start with the first row. For English teacher assessment, we've gone 68 up to 72 up to 75. In English tests and tasks, we've gone from 60 up to 70 up to 75. For mathematics assessments, we've gone from 66 to 72 to 76, each time increasing. Likewise with mathematics tests and tasks, 56 to 66 to 74. So we can see, taking into account English and mathematics, that there is a general improvement. In fact, Each year the markers got higher in every assessment. So this statement is true. And so the answer to this question is statement 2 and statement 3.